differentiating natural exponential functions. So we know from the last lesson that the exponential function e to the power of something, that was our magic number, that when e happened to be 2.7, then the gradient of the function was the function itself. Okay, so f of x is equal to e to the x. We learnt that the gradient function is also e to the x. Absolutely amazing. So let's differentiate some functions. I'm also going to add in some your terms for you to practice, and let me just find them over here. Okay, so let's draw them in now. 3 root x plus e to the x, negative 2 e to the x, and e to the 2x take 4x squared. Okay, so let's have a crack at these. Now part A, we are just going to differentiate like normal, and remembering that e to the x when we differentiate becomes e to the x. Okay, so let's have a go at A. So this one becomes 3x squared plus e to the x. We can see that e to the x stays e to the x, but we still differentiate x cubed as normal to 3x squared. Let's do B. So this is 5 lots of e to the x. And that's a gradient function, 5 lots of e to the x. There's no changes there. And C, we have this exponential function up here. And what we can do is we can use our chain rule. So I can say this is y is equal to e to the u, where u is equal to x squared take 5x plus 1. And then I can differentiate this going, okay, well, I know that dy by du is going to be e to the u, right? But then we can use our chain rule to find dy by dx. So dy by dx is going to be dy by du times by du by dx. Okay, so now we need to differentiate du by dx, which becomes 2x take 5. So let's put it all together. Dy by du, e to the u, times by 2x take 5, and then we can sub in that u value again. 2x take 5 to the power of e to the power of u, which was x squared take 5x plus 1. Now we do learn a shortcut for how to do that in the next lesson, but for the time being we can use our chain rule to help us handle that. Okay, so we're going to have a go at the your turns now. Have a go at the right hand side, pause the video and press play when you think you've got it, and we'll have a go through. Okay, so let's go through the your turns now. First step, put as a fractional power, and then we can differentiate. So we've got 3 on 2, x to the negative half plus e to the x, and you can rewrite this if you want like that. Okay, let's have a look at the next one. It's actually pretty good. Y dash is just going to be negative 2 e to the x. If you just have a multiplier, it just stays the same. Next one, we're going to make this chunk u. So u is equal to 2x take 4x squared. If we differentiate in terms of x, it's going to be 2 minus 8x. And now we've got our function e to the u. Let's differentiate e to the u. It's going to be e to the u. Let's put it all together to figure out our chain rule. Dy by dx is going to be dy by du times by du by dx. Let's find out our answer. Dy by du is going to be e to the u times by 2 take 8x, and then sub in uu. So your final answer is going to be 2 take 8x lots of e to the power of 2x take 4x squared. Hopefully it went well there. In the next video we're going to be looking at example 2. Actually, we might as well keep on going. I think this video isn't too long. Okay, so I'm going to put in the your turns now. X plus 1, b 2ex squared take 2x, and then we've got c, which is going to be 3x squared on e to the x. Okay, so let's tackle these ones. Now we've got a new rule. Do you remember our chain rule? If you've got a function to the power, then you simply bring this function down, it becomes a multiplier, exactly like before with the chain rule, and we extrapolate and it becomes this special rule. So do you remember before here, what we could do is we could differentiate this so it becomes 2 take 8x and just put it at the front, and you can see it there, right? So it's just a shortcut. So let's use this shortcut now. We can see that this chunk here is our f of x, so we want to differentiate that, put that at the front. So here we go, and I'll write a here. So for a, y dash is equal to 5 lots of e to the 5x take 2, and you can write that as like that. See, not too bad, is it? So you just simply differentiate the exponent and then bring it down to make it a coefficient, and then just keep the exponential term as is. Let's do b now. We can see that we need to differentiate x squared plus x, bring it to the front, so 2x plus 1 e to the x squared plus x. We're done. Let's have a look at c. Now this one here, x squared times e to the x, we're going to use product rule, okay? So we can call this u and call this v. Now remember, product rule, if you want to differentiate, it's going to be, and we can call it u dash v plus v dash u, okay? So remember that rule. Okay, let's differentiate now. So u dash is going to be 2x, v is going to stay the same, e to the x, plus the gradient function of v to the x, vx, which is going to be the same again, e to the x, times by x squared, and then we can just, in fact, we can probably leave it like that, or you can write it like this. It looks a little bit messy, but I think you'll be okay writing either one there. Okay, well, hopefully that made sense. We're going to go at the your turns now. What I want you to do is have a go at the your turns and then press play to make sure you got it right. Okay, so let's go through the your turns now. First one, you should have 2 lots of e to the 2x plus 1. For b, you should have 2x take 2 times 2, so there's going to be a 2 at the front of that, e to the x squared take 2x. Okay, and you can maybe take it out and you can make that 4x take 1 e to the x squared minus 2x. You can sort of clean that up if you like, but they both look about the same. Next one, C, I'd recommend rewriting this. You can use quotient rule, but you can also use product rule here. So make it e to the negative x, and then we're going to use product rule. So we're going to have y dash is equal to, and we're going to differentiate. So we've got this term and this term here. Okay, so u dash, so this is our u and this is our v. U dash is going to be 6x, and then it's going to be negative e to the it's going to be e to the negative x. We're not differentiating that just yet. Then we go plus, and then we keep this e to the negative x, but we bring it -1 down, of our chain rule, and then we're going to times it by 3x squared, and we can rewrite this as 6x times e to the negative x plus, or we can go take, and we can go 3x squared times e to the negative x. And there's our answers there. I hope you found this video useful. In the next video, we'll be doing one more example to do with exponential functions, finding a key point.